Hello everyone, good afternoon. So today let's start with quadrilateral, and the first topic of quadrilateral is trapezium, and along with this we will do the next chapter, that is 11.2 of class 8 mensuration. So let's see what is trapezium and how to derive it, the formula for trapezium. So this is the figure of trapezium. Trapezium is a quadrilateral with four sides, this and this, with two sides parallel. No equal, nothing is necessary in trapezium. So in this you can see AB is 12 meter, we have mentioned is at H. BC is 20 meter, mentioned is at A. CD is 10 meter, SC, and A is again 20 meter. And so B will be C plus A, like DC plus CB is equals to, then value B is 30 meter. So just keep in mind, we will arrive at the formula of trapezium. So area of trapezium ABD is equals to, you can see, is area of triangle ECD, and area of rectangle ABCE. So you know the area of triangle is half into base into height, so half into EC into CD. So half into EC is H, or you can put the value 12, later we will put the value 12. H into CD is C. So half into 12 into 10, 60 meters. Now you know area of rectangle is length into width. So this is 12H into A. So 12 into 20, this is 240. So what will the area of trapezium? This will be 60 plus 240 is equals to 300 meter square will be the area of trapezium. Now this is by bifurcating it into triangle and rectangle. What if you directly know to how to calculate the area of trapezium? For this you remember the value of B. B is total BC plus CD. So we can write the area of trapezium as half into H into C, that is the area of triangle, plus area of rectangle H into A. H is your base and A is your this side. You can take common H, then it will be C by 2 plus A. If you take the LCM as 2, C plus 2A. Now C plus 2A can be written as C plus A by 2. Then area of trapezium ABDE is equals to H. C plus A is B, you can see here B is C plus A. So B plus A by 2. This can be summed as half into sum of parallel sides, like these two sides are parallel, so sum of this side plus this side, and distance between them is this side. So if you see any trapezium, you can directly apply this formula, half into sum of parallel sides, sum of this side plus this side, and distance between them. So half into sum of parallel side is B plus A. B is this, A is this, because A was mentioned this, so this is equals to this, into this is H, distance between them. We'll see some questions later on. Now area of general quadrilateral. So this is a quadrilateral A B C D. It has four sides, four vertices, and internal angles corresponds to 360 degree. So again by triangulation method, this method is called triangulation method. You will bifurcate this by quadrilateral into two triangles and find the formula, or you can directly put the formula. If you know how to get to the formula, you can directly put the formula. So we'll see first by triangulation method. So area of this figure will be area of triangle ABC this, and area of triangle ADC this. So area of this will be half into AC into H1 plus half into AC into H2. If you take the common, half AC will be common, H1 plus H2. AC is called diagonal, So you can write it as D. So half into D, h1 plus h2, where D is the length of diagonal. So you can directly use this formula. If you are given the length of diagonal and corresponding height from two vertices, you can use this formula, half into diagonal h1 plus h2. Now area of special quadrilateral. Special quadrilateral is rhombus. So rhombus has all the four sides equal. This is the property of rhombus, this side, this side, this side and this side, and they bisect each other at 90 degree. So you have to remember this property of rhombus, that all the four sides are equal. Again, by triangulation method we can form you can derive at the formula of rhombus. So area of triangle ABC plus area of triangle ADC. So this part plus this part. So this half into AC into OB plus half into AC into OD. Now take the common half AC, OB plus OD. OB plus OD is one diagonal, you can see this, and AC is one diagonal. So if you take this as D1 and this as D2, then half into D1 into D2, so where AC is equal to D1 and BD is equal to D2. So if you know the formula diagonal of a rhombus, you can arrive to its area by half into D1 into D2 directly by this formula. You will see all this in our questions below. So we'll solve the first question. Chapter 11.2. So let's open the chapter. It's 9, 10. Sorry, actually I have to keep this open just to save time. Now this is our chapter. And these are just some of the examples. You can solve it by triangulation method. Now we come to our chapter. Now the first question is, the shape of the top surface of a table is trapezium. You can say this is the table whose top surface is trapezium. Find its area. You have to find the area if its parallel sides are 1 meter and 1.2 meter. So you can see these two sides are parallel. This is 1 meter and this is 1.2 meter, and perpendicular distance between them is 0.8. This is 0.8. So you know the direct formula of to find the area of trapezium is half into sum of parallel sides into distance between them. So half into 1 plus 1.2 into 0.8. When you solve it, half into 2.2 into 0.8. You cut it 0.4. 2.2 into 0.8 is 0.88 meters square. So this is as easy. Just put the formula. Now next question. The area of trapezium is 34 centimeters square. Before moving forward to solve any question, just read out clearly what is given in the question and what is required. So every hint is given how to solve that question. So first you have to write what is given very clearly. So the area of trapezium is 34 centimeters square, and also look at the units. That will help you in conversion. And the length of the parallel sides is 10 centimeter, and the area of trapezium is 34, and length of one of the parallel side is 10 centimeter and height is 4 centimeter. Find the length of other side. So given is area 34, length of one of the parallel side 10 centimeter, and distance between them is 4 centimeter. So just apply the formula, half into sum of parallel side into distance between them. Let other side be, let length of other side be x. So 34 is equals to half into 10 plus x into 4 into distance between them. With this 2 times 34 equal to 10 plus x into 2. If you divide it by this side, 34 by 2 is equal to 10 plus x. You cut it, 17 is equals to 10 plus x. When it goes this time, it goes with the subtraction sign. X is equal to 17 minus 10, x is equal to 7 centimeter. So the length of the other side is 7 centimeter. I hope you are getting how to solve the questions. First read the question carefully and write all the given points. Now third, length of the fence of a trapezium shaped field is field ABCD is 120. Length of the fence, okay, if BC is equal to 48, CD is equal to 17 and AD is equal to 40 meter. Okay, find the area of this field. Side AB is perpendicular to the parallel side AD and BC. So here is given BC is equals to what? BC is equal to 48. BC is equals to 48 meter. CD is 17. CD is given as 17 meter. And AD is equal to 40. AD is equals to 40 meter. Find the area of this field. Side AB is perpendicular to the parallel side AD and BC. So AB is perpendicular to the parallel side AB and BC. So this is saying ki AD and BC are parallel. So you have to draw like this. And let you will draw other way, it will not work, because in the last, see the last line carefully, it is written that AD is parallel to BC. So you have to make the line like this. You have to make the diagram like this only. Now what is given here? Length of the fence of a trapezium, means length of the fence AB, BC, CD and ED. This is the length of trapezium. This is called perimeter. So perimeter is equal to sum of all sides. That is given as 120. So AB plus BC plus CD plus AD is given as 120. Now AB, this side length is not given, so you have to calculate. AB plus 48 plus 17 plus 40 is equal to 120. AB plus 105 is equal to 120. Give there, subtract. AB is 15 meter. So this comes out to be 15 meter. Since AB is perpendicular, it is given in the question only, so that is why you read the question very clearly, properly and carefully. Now what is given? AB is perpendicular to parallel side AD and BC. So AB is the height, then AB is the height or distance between these parallel lines. So now you get all the required fields to find the area, that half into sum of parallel side. You just add 48 and 40, and what is the distance between them? This is the 15 meter is the distance. So just put all these values, you will get the answer. Half into 40 plus 48 into 15, half into 88 into 15. So 44 into 15, this is comes to be 660 meter square. So there is nothing in the question, just you have to read it carefully. This is what is been tested by the questions. Now question number 4. The diagonal of a quadrilateral shaped field is 24. So this is the field, diagonal is given 24 and the perpendicular dropped on it from the remaining opposite vertices are 8 meter and 13 meter. Find the area. So this is a very simple question. So diagonal is given 24. I have given you the formula. It is a quadrilateral, then half into diagonal into sum of vertices, length of vertices joined, length of perpendicular dropped from the vertices. So half into d into h1 plus h2. So d is 24, h1 is 13 and 8. So if you solve it, 12 times 12 into 13 plus 8, 28. So 21 into 12, this comes to be 252. So you have to learn the formula. That's why I am saying ki write the formula each time you are going to solve the question. Later on you will be remembered the formula by heart, and then you can use the shortcut, but at the school level you have to write the formula because you have to show the steps how you have solved the problems. When you grow up, give the paper for an entrance exam, then this will be helpful for you. You will directly solve the question in your mind only. You don't have to even write it. So just in one line you can solve it. But at school level, go with the detail. Now next question. The diagonals of a rhombus are 7.5 and 12. Find the area. Very simple again, not wasting much time. You know, area of rhombus is half into d1 into d2. Just you need to solve it. Simple mathematics. I will not explain much in this. 45 centimeter square will be the answer. Now question 6. This is a important question and little bit tricky question. You have to use your mind of the previously what you have studied. Find the area of rhombus whose side is 5 centimeter and whose altitude is 4.8 centimeter. If one of the diagonal is 8 centimeter long, find the length of other diagonal. So what is given? Side is 5 centimeter, altitude is 4.8 centimeter. One diagonal is 8 centimeter. You have to find the other diagonal. You have to write all the given parameters. Now consider this rhombus as a parallelogram, because parallelogram is also a quadrilateral. So what is given? Side and altitude. So with this area of rhombus, which is also a parallelogram, it comes out to be base into height. So base is given and height is given. So in this case area will be the same. Area of this will be same as area of this, because sides are same. And just for one more option is what is given, it is the altitude, just to find out the area. So you can find area is base into height. If you remember the parallelogram, consider this as a parallelogram. This is the base and this is the height. So you find the area as 5 into 4.8, 24 centimeter square will be the area. Now in this figure, one diagonal is given, you have to find the value of other diagonal. So area of rhombus half into d1 into d2. 24 is equals to half into d1 into d2. So d2 is 24 into 2 by d1. 24 into 2 by d1. So it will be 6 centimeter. d2 will be not 3, this is 6 centimeter. So this is tricky. You have to just consider your earlier concept that it can be treated as a parallelogram also if the altitude is given. So first calculate the area from that one and then put the values while calculating the area of rhombus. Now question number 7. This is also important because in this you have to consider the change in this measurement. The floor of a building consists of 3000 tiles. This is the number of tiles 3000 which are rhombus shaped, and each of its diagonals are 45 centimeter and 35 centimeter in length. Okay, find the total cost of polishing the floor. If the cost per meter, here is given cost per meter and here the values are given in centimeter, so you have to make it to the one dimension only, either in centimeter or in meter, and the cost is per meter square is rupees 4. Okay, so we will write down the given parameters first. Let me just zoom it out. The number of tiles is 3000 and it is rhombus shaped. D1 is given 45, D2 is given 30 for each tile. Each tile these dimensions are given, and cost per meter, cost of polishing per meter square is rupees 4. So these things all are given. Now with this given figure we can calculate the area of one tile. I am writing half. This is half into D1 into D2. So this comes 15. Just a second. So 45 into 15, 25 to 22 and 45. 5, 7, 6, 675 centimeter square is the area of one tile. So now number of tiles is given 3000 and area of one tile, so you can calculate the area of entire room, that is equal to area of one tile into number of tiles. But before going, let's see how to make the conversion. 1 meter is equal to 100 centimeter, so 1 meter square will be 100, that's squaring this 100 square is 10,000 centimeter square. So 10,000 centimeter square will be 1 meter. So 1 centimeter square will be 1 upon 10,000. And what we have got? So 675. What we have got the area of, what we have got the area is 675 centimeter square will be 1 by 10,000 into 675. If you put this for this 0 for this 0 for this again you will come 0, it will come as 0.0675 meter square. In meter square it is 0.0675. Now for 1 meter it is given. Now you calculate area of total floor, so it will be just So area of floor will be total floor 0.0675 meter square into 3000. So if we can write this as, it's a very is equals to 0.0675 into 3 into 1000. So 30 comes with this 67.5 into 3, 67.5 into 3, 17, 21, 22, 2, 18, 19, 20. So 202.5 is the area of total room. Now cost of polishing 1 meter is equal to 202.5 meter square is the area of total room. So cost of polishing 1 meter square is rupees 4. Now 202 is 4 into cost of polishing 202.5 meter square will be 4 into 202.5, just 202.5 into 4, 20, what to get 0 1 4 on 5, 4 to the 8 rupees 850. So sorry, it is, this will be 1. So it will be 810. So you just see a slight mistake caused the use blunder. So you have to take care of this mistake. You have to use the formula quite precisely and quite very carefully. Sorry. So we have done up to question number 7. Now question number 8. Mohan wants to buy a trapezium shaped field. Its side along the river is parallel to at twice the side along the road. So this is twice of this. So if this is x, this is 2x. It is written. If the area of this field, area is given 10500 and the perpendicular distance between the two parallel sides is 100 and this is 100. Find the length along the river. So you have to find the value of this 2x, means you have to find the value of 2 and multiply it by, find the value of x and multiply it by 2. So let's say given is area of field and distance between two parallel sides is 100 meter it is given. So let this considered as x and this as 2x. So putting this in the this is a trapezium. So putting this in the formula of trapezium, we will get half into sum of parallel sides, half into x plus 2x into distance between them is 100. So half into area is 500, half into x plus 2x into 100. So half, if you cut 50, x plus 2x is 3x into 50. So 3x into, you can write it this also, 3x into 50 is equal to 10,500. 3x equal to 10,500 by 50. If you cut, it will become 210. X will come as 70. And length along the river is twice of the length along the road. So length on the river is 2x. It will be 140. So these are some simple questions. Now look at question number 9. We have only 11 questions here. Top surface of a raised platform is in the shape of rectangular octagon. This is a rectangular octagon. This part is rectangle and total sides are 8. So this is termed as octagon. As shown in the figure, find the area of the octagonal figure. You have to find the area. So there is not a single formula to find the area of octagon. You have to bifurcate it into different shapes. So let's see how we can find. We have drawn the area. Now we can see this upper part forms one trapezium and this lower part forms one trapezium, and this is the rectangle. So we have to find the area of this trapezium, area of this rectangle, and area of this trapezium. Now what is given? Distance between this is given 4 and this side is given 11. Same is, this is 11 and this is 5. So for trapezium you got the sum of parallel sides, this side and this side, and distance is 4. And for rectangular you got the length and width. Just to put it in the formula, half into 11 plus 5 into 4. This is the area of this trapezium, plus 11 into 5. This is the area of this rectangle, and half into 11 plus 5 into 4, it is the upper trapezium. If you solve it, it will come 32 plus 55 plus 32. 64 plus 55, that is 119 meter square will be the area of this octagonal figure. So just what important is formula. Now question number 10. There is a pentagonal shaped park as shown in the figure. For finding its area, Jyoti and Kavita divided into two shapes. So what is given? This side is 15, this side is 15, and this side is also 15. Means this is a perfect square. This is equal to this, this equals to this, and these sides are equal. You can see total height is given 30 and this is given 15. Now Jyoti has divided into two halves, making it two trapeziums, this and this, and Kavita has make it a triangle and a square. So just I am explaining here also. So how to calculate the area from the Jyoti's diagram? You have to calculate the area of this trapezium and this trapezium. This is given as 30 and this is given as 15, and this is given as 15. So this will be 7.5 and 7.5. So distance between them is 7.5 and sum of parallel sides are 30 and 15. Let us explain here. While finding Jyoti's way, area of figure will be area of trapezium this plus area of trapezium this, half into sum of parallel sides this plus this is 30 plus 15 into 7.5. You can calculate it twice also because both the figures are identical, but I have written it separately. So this plus this, and so you can write it half into 30 plus 40 15 is 45 into 7.5 into 2, because this and this are same. So this half cancels to this, so area will be 337.5 centimeter square. Now if you go by Kavita's way, so you have to find the area of triangle CBD and area of square ABD. So area of triangle is half into base is 15 and height is given as 15. Total height is 30. You can say check in the figure. This is 15 and this is 30. So this will be 15 only. So base is 15 and height is, and area of square is 15 square. So 225 by 2 plus 225. This is 112.5 plus 225, 337.5. So area in both the case will be same, only the method of finding the area is different. Now to the last question. Diagram of the adjacent picture frame has outer dimensions. This outer dimension 24 and 28. So this is 24 and this is 28. And the inner dimensions 16 centimeter and 20. This is 16 and 20. Find the area of each section. You have to find the area of each section. This of the frame. If the width of each section is same, width is same. What does this line mean? That this is 24 and this is 16. So this is same and this is same. How it will come be same? So 24 less 16 is 8. So then this will be 4, this will be 4. Then only the width will be same. And by saying width is same, it means the distance between them, because this is a trapezium. You got the length of parallel sides and you got the width also 4. In this side also 28 less 20, it is 8. Okay, so this is 4 and this is 4. So for all the 4 figures we got the distance between them, that is 4. And length of parallel sides is, you can easily see 28. This is 28, this is 28, this is 24, this is 24. So just see the solution. Now this is 4, this is 4, this is 4, this is 4. So distance between them is same. So area of each section is equal to area of trapezium. Area of this trapezium, this trapezium, this trapezium and this trapezium. So just write it 4 times. Half into 24 plus 16 into 4. This is this trapezium. Half into 28 plus 20 into 4. Second trapezium. Half into again 24 plus 16 into 4. Third trapezium. And half into 28 plus 20 into 4. That is the fourth trapezium. We are not adding it, we are just calculating it separately. So we are solving 40 into 2, 24 plus 16 is 40, 22, this is 28 plus 22 is 28 plus 20 is 48 into 2, again cut this 40 into 2 and 48 into 2. So 40, 96, 80, 96, 80 and 96. So this is 80, this is 96, again this is 80, this is 96. So these are the area of 4 sections. So I hope you understand the concept of trapezium, parallelogram and rhombus. So you just saw what one mistake made every calculation change. So just keep in mind, keep doing the practice, that will help you out not to have such kind of mistakes in the examination hall or while you are practicing. So thank you everyone. Next chapter will be solid shapes, so we'll come with again with the solution 11.3. Till then, keep studying and have a nice day. Bye bye.